This is 6.1. This is part 3, talking about roots and radical expressions. Okay. Now, we talked in part 2 about numbers and how to kind of break down different roots with numbers. And now we're going to add in some variables with some exponents and things like that. Okay. Now, all this information that's up here, okay, I put this in here just so you can kind of get an idea. We're not going to really use it that much. We're going to use everything. We're going to assume that all variables are positive so that we don't have to worry about whether we have to have an absolute value around it or not. Okay? So, just simply as we look here, the directions to breaking down and simplifying radical expressions. Okay? First thing we're going to do is break down the number underneath the radical to match the index. Okay? Now, this is the exact same thing that we did in class today. Okay? Once you've done that, you want to next take the exponent of each base and divide them with the index. Now, as we look at this, okay, most of the time the problems you're going to see today, but eventually we get down the road here, these are not necessarily going to go into each index, okay, and we're going to talk about those later. All right, so again, you're going to take the exponent of each base, no matter what variable it is, divide them with the index, and that's going to help you take care of the root. If the exponent does not go evenly into the index, you leave whatever's left over inside the root. Okay? For example, let's say you had the fourth root of a to the sixth. Well, 6 divided by 4, 6 doesn't go into 4 evenly, or 4 doesn't go into 6 evenly. So I could rewrite this as the fourth root of a to the fourth times a to the second, which is essentially using your exponent rules, which we talked about in part 1. Okay? Once I do that, now this a right here, these 4 will cancel out with that 4, and it's going to go out on the outside of the root, but the 2 that are left over will stay on the inside. So that's an example if you don't have a number that matches up. Most of the numbers today are going to match up for you. Okay? All right, so let's take a look at some examples here. Okay, so we've got the square root of 16x to the 8th power. And in the directions say, what is a simpler form of each radical expression? So, first thing I want to do here is I want to break down my square root to my number underneath the square root to a power of 2. So really this is 4 squared times x to the 8th. Remember, there's a 2 up here. Okay? So, again, for every 2 with the root, it's going to cancel out. So what I want to do here is I want to take 2 divided by 2. 2 goes in there evenly, so my 4 is going to be outside the square root. Okay, I use the square root, the square and the square cancel. Okay. Now, as you look at this again, I've got 8 x's down here. So if I take 8 divided by 2, I get 4. So I'm going to take x to the 4th, and then this is my final answer. Okay, so you're going to divide your exponents. You'll notice again here, I take each exponent, 8 divided by 2 is 4, and 2 divided by 2 is 1, so really I have 4x to the 4th. And you'll notice this, once I use the root, it's gone. There's nothing left over there. Okay, so letter B here, I've got variables. Okay, so again, I'm going to take 6 divided by 3. I get 2 left over, so I have a squared. I take 9 divided by 3, that's 3, so I have 3 left over, and you'll notice my root's gone. I used my root to simplify that expression. Okay? So in this case, example C, I take 8 divided by 4, I get 2 left over. I take 12 divided by 4, and I get 3 left over. Okay? Essentially, if I were to write this out the long way, this would be the x to the 4th times x to the 4th times y to the 4th times y to the 4th times y to the 4th. Okay, I'm looking at this problem here. If I were to write this out the long way, each one of these 4s that you have here will cancel out with this 4 right here, which means you have 2 x's left over and you've got 3 y's left over, which is really x squared y to the 3rd. So instead of writing these out every time, we're just going to divide those through. Okay, so what's the simplified form of each radical expression? Letter A here. Again, I want to break down that number So I've got the square root of, instead of 81, we're going to make this 9 squared and x to the 4th. So the squares are going to cancel, so 9 comes here. And if I take 4, divide that by 2, I end up with 2 x's left over, and this guy is my answer. Okay? Again, we're assuming that all variables are positive, so I don't have to worry about certain things with absolute values. Okay? So, letter B, 12 divided by 3 is 4, so I have 4 a's left over. 15 divided by 3 is 5, so I've got 5 b's left over. Okay, and then the letter C, 12 divided by 4 is 3, and 16 divided by 4 is 4. Okay? All right, so these were pretty simple examples as we look here for part 3 of section 6.3. Now, we're going to put all this together. Don't forget to complete your WSQ for section 6.1. Okay? It's going to include everything. It's going to include exponent rules. It's going to include how to break down number roots. It's going to also include how to break down radical expressions. Okay, so don't forget to complete that WSQ. All right, this concludes section 6.1, part 3 of the notes.